Hi guys, I am Dr. Nandabalaji. Today we are discuss about the topic of non-destructive testing, introductions and types of defects and methods. First of all, non-destructive testing is NDT ensuring integrity and safety. Non-destructive testing is a critical discipline safeguarding industrial assets and public safety. The global NDT market is projected to reach of 11.5 billion by 2028, reflecting its indispensable role in preventing catastrophic failures and saving lives across various sectors from aerospace to oil and gas and manufacturing. NDT ensures that reliability and longevity of vital infrastructures. And what is non-destructive testing? In integrity without damage, NDT allows for the evaluation of materials, components, and systems without causing any physical damage to the test object. This preservation is key to maintaining asset value. Detecting hidden flaws. It identifies defects, continuities, and variations in material properties that might otherwise go unnoticed, ensuring compliance and preventing failures. Quality and safety assurance. NDT is fundamental for quality control and safety, playing a crucial role throughout the entire asset management life cycle from manufacturing to in-service inspections. And why NDT is crucial for industries? It's like as a cost efficiency, prevents costly downtime, expensive repairs, and premature replacements of equipments. And regularity compliance ensures adherence to stringent industry standards and codes such as ASME and API, avoiding penalties and legal issues. Risk mitigation significantly reduces environmental hazards and safety risk to personnel and the public by identifying potential failures early. Extended lifespan, proactive detection and monitoring can extend the operational lifespan of critical equipment by up to 30%, optimizing asset utilization. Common material defects, surface flaws. Surface flaws are visible or non-surface imperfections that can lead to significant structural problems if not detected early. Fatigue cracks, initiated by repeated stress cycles, these often start at the surface and propagate over time. Corrosion pitting, localized material degradation creating small holes due to chemical or electrochemical reactions with the entire materials. Surface porosity, small gas filled voids typically formed during the solidification of molten material or welding processes. In common material defects, subsurface flaws. Subsurface flaws are hidden within the material and require specialized NDT methods for detection. Internal voids. Hidden packets are shrinkage defects within casting or welds often caused by gas entrapment. Inclusion, non-metallic particles or impurities trapped inside the material during its manufacturing process. Delaminations, separations of layers in composite materials or rolled plates, compromising structural integrity. Lack of fusion or penetrating. Unbounded areas within welded joints where molten material sits can role play with the base materials. Overview of NDT methods. NDT encompasses a wide array of techniques, each tailored to detect specific types of defects in different materials. The selection of the appropriate method depends on the material's properties, the types of defect expected, and accessibility like as visual, direct observation, acoustic, sound wave analysis, electromagnetic, electrical or magnetic field analysis, X-rays or gamma rays analytics, these kind of NDT methods. Key NDT methods one, maybe like as VT and PT, visual testing and liquid penetrating testing. The most fundamental and common NDT method, detecting up to 80% of surface defects, it relies on direct observation with aids like magnifier boroscopes and proper lighting to identify surface irregularities, correction and misalignment. Liquid penetrate testings used for detecting surface breaking flaws in non-porous material like materials, plastics and ceramics. A liquid penetrate is applied, seeps into defect via capillary action and is then revealed by a developer making the flaw vessels visible. Key NDT methods to magnetic particle testing, MT and eddy current testing. Exclusively for ferromagnetic materials, magnetic penetrating testing defects surface and near surface cracks. A magnetic field is induced in the part and magnetic particles applied to the surface cluster at discontinuities indicating flaws. Eddy current. Ideal for conductive materials, eddy current testing uses electromagnetic induction to detect surface and near surface cracks, measuring coating thickness and short materials. Changes in the eddy current flow caused by defects or property variations are detected by a coil. And key NDT methods 3, ultrasonic testing and radiographic testing. Ultrasonic testing utilizes high frequency sound waves and to detect internal flaws, measure material thickness and characterization bond integrity. Transducers generate sound pulses that reflect of discontinuities, providing data on their location and size. Radiographic testing employs X-ray or gamma ray to produce a permanent vessel record of internal flaws such as voids, inclusions, and cracks. The radiation passes through the object and varying absorption due to flaws it's captured on film or digital detectors. Conclusion. NDT, the invisible guardians. NDT is the unseen force that ensures the structural integrity and operational safety of our world's critical infrastructure from bridges to aeroplanes. Its methods and are indispensable in preventing catastrophic failure and mitigating risk. The continuous innovation in NDT methods, including advanced techniques like phased array ultrasonics and digital radiography, is constantly expanding its capabilities, making it even more vital for quality control, predictive maintenance, and overall safety across all industrial sectors. Thank you, guys. Thank you.